Hello, welcome back. In this video, I'm going to be going over 3 ACT math questions. For all these problems, I recommend pausing the video and trying all the problems yourself first before you see me solve them. Without wasting any time, let's get into it. Question 15 says, a large circle with radius r inches is shown in the figure below. 3 small non-overlapping circles, each with radius r inches, are removed from the large circle. The shaded region is the area of the large circle remaining after the 3 circles were removed. What is the area in square inches of the shaded region? So for this question, we need to know how to find the area of a circle, which is pi radius squared, right? R squared. And what we basically want to do is we want to get the area of the whole circle, right? And we want to subtract the area of these 3 little circles, right, from the area of the large circle. And notice all the little circles have the same area, right? Because they have the same radius. So let's find the area of the large circle. So pi r, big R, right, squared, minus the area of these 3 little circles. Notice that the area of one of these circles is pi r squared, right? And since there's 3 of them, the area of all of these is going to be 3 times the area of one circle, right? So this is going to be 3 pi r squared. This is the combined area of all 3 small circles. So it's going to be pi big R squared minus 3 pi lowercase r squared. So the answer to this question is E. On to the next question, question 45, which says, a certain triangle has a perimeter of x meters. One of the triangle is 60 meters long. Another side is 1/3 the length of the perimeter. And the third side is 1/4 the length of the perimeter. What is the perimeter in meters of the triangle? So remember, the perimeter is when you add up all sides of the triangle, right? So you would add up all 3 sides of the triangle. So in this case, it's going to be 60. Let's call that our first side, plus the second side. We'll just leave a dash there right now. Plus the third side. We'll also leave a dash there right now. Equals the perimeter, which is x, right? Notice it says that another side is 1/3 the length of the perimeter, which we called our second side. 1/3 the length of the perimeter, that is 1/3 times x. So the second side is x over 3, right? We can fill in this dash with x over 3. And the third side is 1/4 the length of the perimeter, which is 1/4 times x, which is x over 4. So the third side is x over 4. And we can fill this dash in with x over 4. Now we can just solve for x, right? So 60 plus x over 3 plus x over 4 equals x. Let's combine these first. $60 plus 7x over 12 equals x. Subtract 7x over 12, right? X is the same thing as 12x over 12, right? Minus 7x over 12. That's 5x over 12. So 60 equals 5x over 12. And if you were solving for x, you have to multiply 12 to both sides. So 720 equals 5x. We are solving for the perimeter, which is x, right? Divide by 5, divide by 5. And 720 divided by 5, that is 144. So the answer to question 45 is E. On to the last question, question 60, which says, given f of x equals the cube root of x plus 2, which of the following expressions is equal to f of negative 1, x for all real numbers, x? So for this question, what I would do first is replace f of x with y. Then I would swap y and x. And then for the third one, I would solve for y. This is how you solve basically any problem that asks you to find an expression equal to the inverse. This is the inverse notation for a function. So replace f of x with y. So y equals cube root of x plus 2, right? Now we want to swap these. So x equals the cube root of y plus 2. And since we're solving for y, this is going to be, to cancel out the cube root, you're going to cube both sides, right? If you cube the right side, you have to cube the left side. So it's going to be x cubed equals y plus 2. And I'll subtract 2 to solve for y. So you get x cubed minus 2 equals y, right? And that's all you do. So the answer to question 60 is F. I hope my explanations made sense, and thank you for watching.